Hi everyone, welcome back. Today we're going to look at colors and how to use color effectively in data visualization. So in previous videos, you probably saw that I use black and white a lot, or grayscale a lot. So you probably got pretty bored about that. And actually, even using just grayscale can be pretty risky, and it needs a lot of thinking. Here's a quick quiz for you. So on your screen, you see there are 4 rectangles, small rectangles in gray. Which one is darker? You probably may see that the left one is darker and the right ones are lighter. But actually, they're the same. So the reason that we perceived the left one to be darker was because it was in front of a white color, and the one to the right where you saw it was lighter was because it was in front of a darker color. So what that means is that how we perceive color actually is affected by the context and also by the color surrounding what we're looking at. Color is very powerful, however. So if we can use it appropriately, we can call attention to the right amount of information that people should care about. We'll make it more attractive, increasing the appeal. It might help people to better remember your visualization. And of course, it adds another dimension for you to work with. So you can use different colors to encode information. So now we're going to understand a little bit more about color and how to best leverage it. We'll first start with the ways to represent color digitally. And RGB colors model is the most common way to do it. And it is what we call an additive color model that's based on mixing red, green, and blue light together to create different colors. So it's very commonly used because a lot of devices like our cell phones or our TV, the colors are generated based on the combination of these light. However, even though we see in RGB, we don't really necessarily interpret things in RGB. The more intuitive way to interpret color is actually using the HSV Color Model. So this is a color picker from an illustration program called Affinity Designer. In the HSV model, H means hue, or what most people call color. And S is saturation, and V is lightness. So hue is pretty easy to understand. So you can just by looking at it, is this the kind of rainbow hue going around. And for lightness, you can think of it as how do we get a lighter red? So as in by adding more white. For saturation, you can think of it how to remove the color, like desaturate, or like adding more gray to it. So this is actually a more common way for people to interpret color, because often we start with mentioning the hue. And very rarely we'll say, it's maybe lighter red, lighter blue. And saturation, usually we don't even mention it. But nonetheless, that's actually a very good way to also represent color. If we look at just hue, that can be problematic. The main reason is because how you interpret can actually depend on your gender, your age, and so on. For example, it seems like for girls, there are a lot more definition for different shades of green. While if you're a guy, then you probably just say, there's just one green. So this is a very interesting illustration that kind of show you how the two genders might compare. So when you use color, you need to be very careful, because about 10% of males and 1% of females in the world are red-green colorblind. So that means if your visualization design depend on using red and green to distinguish between values, then about 10% of the population actually cannot tell the difference. And there are even more people who are colorblind. So that means they may have a hard time of distinguishing any color. For example, here, if you have a normal vision, then you can see 74. If you are colorblind, then it might come out as 21. And also when picking color, you want to pick a scale that would not accidentally give you some unintentional meaning. For example, here we are using a color scale that goes from white to dark blue, and then transition to red and to yellow to encode temperature. And take a moment and see what you see in the image. You probably say, this is like something on fire, right? So because you're using yellow and red to encode a higher temperature. But is this really what you want to convey in your message? Probably not. You probably won't want to say that the more southern states are on fire, right? So this is an intentional use of color scale. And also, when you use color, don't go overboard. There's a downside of doing that. For example, you may think that using more color probably better, right? So I make it more attractive and so on. But it's actually not good for a lot of quantitative data. For example, you may have values that are in a range, let's say between 0 and 1. But then you decided that for the lower value, you assign a purple, middle value is yellow and orange, higher value is green and red. Then it's not really good. Actually, it's counterintuitive and really detrimental. The main reason is because we can't really say which color is lower or higher than the other. For example, if I just give you purple and red, would you say purple necessarily is smaller? Or some people would actually say purple is higher. So to help you design more meaningful color scheme, so this is a very good image. So this is a guide for you to look at first what your data is trying to convey, and then pick the appropriate color. For example, on the top left, it's saying that if you only have two kind of information, like binary, yes or no, then you can use shade. Like one is very dark, one is much lighter. And similarly, at the top right, so if you have categorical data, so that means you don't really care about the absolute difference or relative difference. You only want to convey out there actually 3 different categories. Then those two or three colors should be quite different. So in this case, we're using red, blue, and green as far apart as possible. Actually, you may even want to make them colorblind safe so that everyone can see them. So towards the lower left, if your values is between a scale, let's say -1 to 1, so that means you cut across 0. Then you would want to use something we call a divergent scale. So that means you may want to have a neutral middle point, in this case using gray or white as a middle point. And then for one end, let's say negative, we use dark purple. And then towards the right, we use orange. And then anything in the middle would be a gradient. And similarly, to your right, you have the sequential data. So it is very similar to binary data, but in this case, we have more separation or gradation. Instead of only 2, here we have 3. And you can also mix all these up. For example, right in the middle, we not only have divergent information, but also within each color, we also have sequential information. So we end up getting a matrix of color. So this is a very good guide of how you may want to determine which kind of color combination you may want to use. But if this is still too complicated, so this is a very good website you might want to use. It's called Brewer. So an excellent website because it will show you a preview on the right. Here we're showing a map and look at how your colors are applied. And also on the left, you have the option to choose different kind of the color scale. For example, you can pick sequential, and here we pick divergent, which is good for ranges of values as they go from negative to positive. So you have 2 colors here. Or you can pick qualitative, right? So that means categorical. You don't really care about the absolute differences. You only say that there are maybe 7 category, 5 category, and so on. And also even better is on the bottom left of the screen, you get to choose to only focus on the color scales that are colorblind safe or they're print friendly. So that means if you print them out in black and white using black and white printer, it will still show up really nicely. So this is a color picker website that I would highly recommend. So it really takes a lot of the guesswork out. In this video, we look at color and also look at how we may apply color effectively in data visualization. And we should take great care when using color because a big part of the population may not be able to see color. And also we'll talk about a very good website called Brewer for you to choose color scale so that you don't need to do the guesswork.